In the last couple of videos, we've been exploring workflow automation tools and cloud providers' offerings to address this very matter of automating your routines in a low-code manner. The key aspect I've been prioritizing for you guys up to this point has been setting up an automation in the most flexible way so it supports a lot of things you could possibly think of without much effort involved and for the lowest cost. And I want to call it low-code still, because despite working with drag and drop interfaces, there is some coding involved regardless. But the good news is that it's not going to involve any complicated data structures or intricate algorithms whatsoever, though I still think it's somewhat important today. But bear with me for the moment, because we're going to be directing all this knowledge gathered so far to building something practical and hopefully very useful for some of you guys. We're going to be deploying a workflow automation open source tool called N8N that we actually already in fact looked into in one of my previous videos where I got quite excited about. So we're going to be deploying this tool to Google Cloud following some best security and reliability practices applicable for this very scenario so that we don't have to worry much about it afterwards. And that is, guys, going to give you much more than a standard documentation covers. And on top of that, I'm even going to provide you with some functional code. And without further ado, let's get started straight with an architecture.
Let's have a look at the architecture of this solution we're going to be deploying in Google Cloud. Try to show it from the perspective of the people involved. There's going to be a user who cares about service itself. He needs things like performance, reliability. He doesn't want his data being stolen. He doesn't want to lose any progress made. He cares about those things. And there's going to be an admin who actually makes sure that those expectations are met by monitoring key metrics, making necessary adjustments like increasing storage size, adding more capacity, and things of that matter. After you've created an account in Google Cloud and set up a billing profile, the first thing you do then, before anything else, you create a Google project where you're going to accommodate all of your resources. You do that by looking for Create Project option in the drop-down menu. You name your project, you hit Create, you wait a little bit. Once the project is out, it's gonna bring you to the summary page that could be quite helpful, especially later down the road. It shows you some basic resource utilization, API usage, billing information, how much you've spent so far, links to the monitoring, tracing, and a few other things. Next, we need a place where we're going to host our cluster, and we're gonna set up a VPC for that. We're gonna switch to the networking console. We're gonna enable this API first. Once API is enabled, we've got everything to create our first VPC. For that, we're gonna hit this VPC network button. We're gonna type it VPC name. We also want to opt for this automatic subnet allocation so that we don't have to think about networking parameters much. And we want to leave these firewall rules default, and we'll change them later if necessary. Once done, hit this create button. Could take another minute to instantiate the subnet. Once done, you should be able to see it in the list of networks right here. Next, we're going to go after Kubernetes, and for that, we're going to search for it in the console menu. We're going to enable this API. Now we're finally ready to create our first cluster, and let's actually do that. Let's hit this create button. Whenever you're on the cluster creation page, it's going to suggest you to use this autopilot version. You always have a choice to switch over a standard one, but I wouldn't recommend to do it for your first thing. They are fully covering the cost of a single autopilot cluster, and it's better, more resilient than a free zonal cluster. Because turns out they can afford it. You can't take advantage of an excessive capacity in this model. The lowest resource you can choose may be too high for some of your things. But what I can tell you that it would still be cost efficient as long as you have less than 10 services of a low scale. Is going to be better and cheaper than if you set up a standard cluster with regular nodes. Besides, you're also given 300 credits if you just created your Google account, so why not? It's gonna ask us for the name. I'm gonna give it my conventional name. I'm gonna leave the region central for sustainability reasons. Next, we're gonna phase this networking settings, where we're gonna select our network we've just created. For that reason, the cluster is going to remain public, but don't worry, because it's still going to be protected by authentication, so that only you who holds this certificate is able to access it. Next, you're gonna phase these advanced settings, where we're gonna leave everything by default, because it's pretty much well optimized for the first use anyway. The only thing I want to enable is just some metrics for the workload. Okay, I might need them at some point. We skip the fleet page, and after verifying all the settings, I'm gonna hit this create cluster button. Alright, we finally got our Autopilot cluster, so let's go and see some of the details. We see that it's regional, which is great because we're getting a highly available cluster for free. We see that a control plane resides in 4 different availability zones, definitely good for resiliency. There are some networking settings, security settings, and features have been enabled, though a lot of things are disabled, but those are either legacy, they're not supposed to be enabled, or not essential for our first project. The second tab contains information about storage volumes that you created or about to create using one of these available drivers. There is an observability tab showing all of the metrics and dashboards, and remember those metrics are enabled, they're going to show up right here. There is another tab containing logs coming from your services, also very important, very convenient as well, because they are right there. You don't need anything else. You can look through them and search through them using various filters and such. Now we're gonna try to connect to the cluster, and the simplest way to do it is to use this Cloud Shell. For that, we're gonna open up this Actions menu and choose Connect. As you can see, it's giving us a command which we can execute either locally or in the Cloud Shell. And for the Cloud Shell, it's even giving us a quick link. Let's hit it. It's brought us to the Cloud Shell, and it's also inserted this command into the prompt, so that the only thing is left is just to hit enter. So as you can see, I got authenticated against the cluster using my current credentials, and from this point on I can interact with the cluster using a regular flow, such as kubectl command, for instance. There you go. It shows that there is a node pool available for me to use. Next up is this actual installation of N8N on Google Cloud to GKE in particular. We're gonna go through this page to see what it involves. And at this point, I'm going to be switching over to VS Code IDE, where I'm going to be putting the project together file by file, and we'll keep updating this README so that I can release this project in a GitHub repository along with a video for you to have something to work with afterwards. We're going to need a couple of things here before we start interacting with Google Cloud environment and GKE in particular. We're going to need this gcloud command line tool for authentication, for interacting with GKE through API using command line. We'll get to it. We're gonna need this plugin as well, which will allow us to authenticate against the Kubernetes cluster in GKE and kubectl. It's not mentioned here. We also need it installed in our local environment to be able to carry out all work mentioned here down in this document. In order to have gcloud CLI in your system, you can just follow this page. It has all of the installation instructions for the most popular operating systems. I'm gonna attach a link in the README. You can also just simply Google it. I'm gonna follow this Ubuntu version, even though being on Windows, because I'm making a great use of WSL, which I recommend you to if you on Windows as well. It provides with a perfect Linux environment for these kind of things. The actual installation comes down to a couple of commands here. We're gonna install the dependencies first. They're gonna be required for the CLI to function. We're gonna add these repository sources and the public key to trust this source. And then we're gonna install the CLI itself by launching this. Though I have already it installed, I'm gonna just basically update Google CLI. And I'm gonna print out the version to make sure that we have it installed in the system and it's accessible from the command line without needing to do anything else. I'm gonna print out the version, and there you go. So I've got the version installed. There's like a beta build as well available, a couple of additional components. So we're good to go. Next, we're gonna install this plugin, and if we hit this link, it's gonna bring us to the page with the entire blog article written on the topic saying that this plugin, in fact, is no longer part of an open source package, so we gotta install it separately, but good for us. Google actually provides us with this component installation flow that comes as a part of a gcloud tool suite. So let's go ahead and install this thing. I'm gonna execute this command. I'm gonna confirm the execution. It's gonna take some time to install it, to put it in place. There you go, the plugin is in place, and now let's try authentication. Lastly, you need this kubectl tool install, and gcloud is super helpful with that as well. Just run this, confirm installation, and there you have it. Next on the list is authentication against the cluster, and I have a couple of commands here for that. First, I want to be authenticating against the Google Cloud account where I have my cluster running. So there is a command for it. It's going to give me the link, which I should open in a browser session and choose the account that I used in the console. I'm going to generate this token and pass it over onto a command line tool. And there you go. It says that I am logged in as this user. Okay, so now I can list my clusters. It's showing that one cluster is running currently in central region. That's correct. And another thing I want to do is I want to generate credentials for this cluster, and there is a command for that. Works perfectly well. Now what it does is that it generates this kubeconfig entry based on my permissions in this particular account. So given that I'm an admin, so it's obviously giving me admin permissions for that reason. So, and now after a file being generated, I can finally start interacting with this cluster using regular kubectl commands like get nodes and get pods, for instance. It's showing me there's like a couple of things already running there because it's like autopilot cluster, and it manages for you a couple of things. And that brings us to the most interesting part, which is installing the service itself along with the dependencies it relies on. They have this repository with all application configuration files that we're going to be applying to our cluster and observing the behavior. I'm gonna pull this repository to have it locally available so that I have all those files to look through and work with and apply against the cluster. I'm gonna be using this command for it. If you don't have it, just go ahead and download it for your system. Should not be a big deal. So after executing this command, it's gonna create this folder, and in this folder there's like gonna be a bunch of files, and let's go through them one by one. Once you're done with the cluster, we're gonna need a couple more things for a more robust setup, and that's before the actual service installation. These are the things that are external to the cluster, so you're gonna configure them outside, and I recommend doing it in the console, though console doesn't have a capability to configure everything in Google Cloud. So some things like managed certificate map, for instance, being a fairly new offering, aren't apparently available in the console. So you gotta configure it using gcloud or API. I'm gonna provide you with a snippet and instruction how to do that. Let's take it one by one. What do we need these things for? External domain name. That is something that you're going to use to access your service in the web browser. It's gonna be your endpoint, right? So, and it's not only for the sake of having an alias to access your service, but also it gives you a good security model, because all of a sudden these encryption protocol like TLS, SSL pretty much rely on it, so you gotta have it. Next, managed certificate map, pretty much for the same reason. In order for encryption to work, you gotta have this certificate that your browser is going to check against, right, during this session. So that is a thing that Google offers that automatically kind of rotates expiring certificates, so you don't have to worry about it. Identity aware proxy, so your endpoint is going to be publicly exposed. You don't want anybody on the internet use your service. So this is the simplest way to do it with Google Cloud. You just set up identity aware proxy in front of it, and it's going to give you this sort of like SSO page where you log in using your Google credentials against Google Identity Provider. And as long as the permissions is given, as long as you're using specific, say, Google account, it's going to allow you to access the endpoint behind. And the last thing in this list is Cloud Armor. And you really want to have it, because this is like the simplest way to protect your service against various sort of attacks, including distributed denial of service attacks that can get quite scary. And it does it by using this intelligent mechanism of identifying various attacking patterns and setting up dynamic rules to block all this traffic out, so it doesn't even get into the system, which is good. It also gives you a protection against bots by challenging users to resolve captures, so it's all like configurable behavior. One of the way to address the domain situation is to use Google Cloud DNS, though it could be any DNS provider, and I figured, why would I make my life more complicated? I would just put everything in one basket and be done with that. That is what I did. And the way you do it, if say you own a domain somewhere else, could be GoDaddy or Squarespace, whatnot, so you're in control of all of the records there. So you create a zone here under that domain, and then you create the NS record there with all of these name servers mentioned here in this block, so that like DNS clients actually know where to look for the like records on a deeper level. After this setup, I'm in control all of these like child records, and I can easily assign new domain names to the services I create in Kubernetes cluster. For the SSL certificate, we're going to be using this managed certificate map service so that we don't have to think about rotating our certificates all the time. Unfortunately, there is no visual interface in Google Console to manage those, so we're going to be using our local shell along with the gcloud tool to do various operations about it. One of the things you need to think about is this DNS authorization, and that is a way for a certificate authority to confirm your ownership of a particular domain. And to make it work for wildcard domains, it really just comes down to a single option, which is DNS authorization. The way it works is that you create authorization and you print out the details, and it's asking you for a challenge. You gotta create this record in your domain with this value for it to confirm it. Once it's in place, you can proceed with creating the certificate itself, associating it with the map, and then actually using this map with your load balancer. Now we are at a point where we are to install service components into the Kubernetes cluster. The authors of this document provide us with the repository that contains somewhat initial configuration we definitely want to make use of. It contains a bunch of files, so-called Kubernetes object manifests, with specification of certain objects that need to be there to function. Okay, if we go back to our initial diagram, we see that only this like a little block in the bottom, what is covered by those objects, whereas this upper side of the scheme that is responsible for exposing the service to your user in the internet on a custom domain name in a secure manner. So those things are missing, though GKE in particular actually provides you with capability to manage these aspects as well. A couple of things we've already done manually outside of the cluster will serve us well as well. So let's get into the specifics. I'm ready to present you with the result of my work that's also going to be available for you if you want to repeat this process. Okay, please check the description, the link should be right there. So what I did is that I took that repo and added a few things to it for the external layer, and I also restructured it in a way so that it's more practical and production ready and has pieces now, right, that can be managed separately. Say if you want to make a data layer more resilient, now you've got options. Also maps perfectly well onto our installation process, which is right here. And we're gonna go through secrets management first. We're gonna install a database right after and bring up a service itself and pair it up with a database. We're gonna test this functionality using local port forwarding, and then we'll enable a gateway that is backed by a global load balancer in this case, and we need that feature for a couple more services that are only available for a global load balancer. I'll explain. We'll activate the routes on the load balancer so the app starts accepting traffic from users on the internet. We'll add this transport layer security through certificates of such. And finally, we'll add this authentication to protect our endpoint. All right, let's see what we've got here. We're gonna create a namespace first because nothing exists without a namespace. So there's a file defining it, sitting right here in the bottom, just the name of namespace, nothing fancy. And we're gonna apply this file against the cluster, just applying it in your terminal. This is the way you do it, and it prints out that it has been changed because in my case it already existed, and I'm not gonna delete the namespace to not disrupt the resources, so it's gonna be a new resource for you. And then the way to check it, you just print out the existing namespaces, and there you go. It is present in our cluster now. Next up, we're gonna deal with the secrets, because secrets, being the prerequisite for the downstream resources, need to be defined first. We've got a couple to work with. There's a Postgres secret that contains user password pairs for so-called root and non-root users. I just suggest you replace these password fields, just generate something random and put it in place. And there's identity-aware proxy secret, which I'm not gonna cover fully in this video because it could stretch it too much. So just follow the instruction online, create this OAuth client. It'll give you the client ID, client secret, and replace those values right here. All right. So then copy paste this folder. That's the way for me to not commit sensitive information into a repository. Just copy and replace those fields in this folder that is grayed out. Okay, so once done, you just apply the secrets, and there you go. They should be displayed there like this. Next, we're gonna install a PostgreSQL database, for which we've got this entire data folder full of files. To explain everything would take a lot of time, so I'm just gonna point you to most important pieces. Postgres.yaml is the most important file. It contains the image version, which you can switch back and forth. Currently, 11th version of PostgreSQL is used. To see what versions are available, you open up hub.docker.com, search for Postgres, see available tags in here, right? Once you know what version you need, you just switch it here, restart the service, and there you go. Resource is another important block, which basically defines how much money you're paying for it and how fast your service is working and how much reliable it is. Currently, the minimum amount of resources specified that GKE Autopilot cluster allows you to. You can go lower than this. This is the lowest amount of money you have to pay for it to run on GKE Autopilot. So, but we start here, and what I can tell, it's more than enough. And then once we see the need for it in our observability suite, we can adjust these parameters. We're going to be installing the app now, which is essentially the same thing, but has a few more files to it. And that is because we're exposing the app to the world through a load balancer. And as such, we need to define a few more things for it, right? But let me start from the basics. Main file, same thing. Define an image here. I can find it on Docker Hub. They support it. Minimum amount of resources, because we don't know how much you're going to be using of those, right? You need to monitor and circle back on it. You don't change the service object, neither the persistent volume claim. I have no idea why they're using this volume storage here. Can probably not that essential as Postgres. All right, anyways, health check, very important. Without it, it's not going to work. That is for a load balancer to confirm that your endpoint is alive, to start sending traffic to it, okay? And the backend policy, that's where you enable some extra features like identity-aware proxy. By commenting these lines, you basically enable authentication, provided that you've got your OAuth client set up, okay? And this is how you protect your service endpoint by Cloud Armor, okay? You just need to create this security policy in the console, give it a name, specify the name here, and then comment this section. Once you're done, go ahead, apply all these files, wait a couple of minutes, and your service is gonna be provisioned like that. Now, let's actually make sure that the service is indeed provisioned and functions well and nice. And for that, we're gonna be switching over to the troubleshooting section, which I put out for you to facilitate this process. So for starters, we're gonna be printing out the list of services in the cluster. We've got a few, as we could expect. So, and now we're gonna do a little bit of magic with port forwarding. For that, I'm gonna be typing in this command that is going to forward this port onto my local port, so that I can in fact type it into my browser window, open this service through the port forwarding feature on my local machine. Isn't it nice? So all works fine for now. Let's move on then. We're gradually approaching a service exposure, and I've got a couple of options for it, guys. You can choose to go with this ingress resource, which is an outdated, old-fashioned way of exposing services in Kubernetes, or you can opt for a gateway API, and that is a better model for collaborative environments. Say you've got a bunch of folks responsible for various aspects of infrastructure, so they need to control things in various namespaces, and you want to have a better control of permissions. This is the way to go. The gateway is going to reside in a separate namespace for that matter, and there are a few new resources I gotta explain. And let me start with the main one. So this is a resource of a gateway kind, and it defines the load balancer is going to be backed up with. So this field actually selects the load balancer. If we take a look into the docs, so this is where we can find all of the available gateway class names and corresponding load balancer types. The one that I'm using is called Global External Application Load Balancer. I could have chosen a regional one to save money, but the reason I've chosen the global one because it supports identity-aware proxy and Cloud Armor, which original doesn't support. And I thought I'd need that more. And I'm getting actually authentication for free with this load balancer without even saying that it's much faster and safer to have your traffic remain on the Google backbone net. The other thing you gotta understand about that load balancer is that you can actually control a lot of aspects of it through these Kubernetes objects available for you by default. You can even do more than what's available in the Google Cloud Console due to some UI limitations, I think. So in my particular situation, what I'm doing here is that I'm defining a couple of listeners to accept both HTTP and HTTPS traffic, and I'm also defining a forwarding rule to redirect HTTP traffic onto HTTPS endpoint, and I'm doing it on the gateway level and putting some restrictions in place so that in other namespaces the only kind of route you can set up is the one that accepts traffic from HTTPS listener. The last thing you don't want to forget about to set up for this load balancer is that a certificate valid for a specific domain name you're going to be exposing your service on. Remember that certificate map we created? So that could contain multiple certificates valid for several domain names for your different kind of services to use. And that's where you specify it here on the gateway level as well. And the only thing that's left is to set up a route for your service. And you do that using this route object. You associate it with a gateway on one hand and with your service on the other hand. And you also specify a domain name where your service is going to be exposed. Once done, you apply that thing to the cluster. You wait a little bit because it could take a little bit of time for it to reconcile on the back end. And then eventually a load balancer will set up a routing rule so that as long as you request your service through the browser using these parameters, it will start accepting traffic. By the way, don't forget to create a record of an A type pointing to your load balancer IP address. If you use Cloud DNS, this is where you do it. You hit this add standard button, fill in the parameters, specify the record type and the IP address itself. I already got one, right? And you can find the IP address on any of your load balancers created. They're kind of combined. This is like the same load balancer whatsoever. And you take this IP address and specify it right here. All right. There is a thing that does that automatically for you. It's called external DNS. Though it's not automatically pre-installed for you. For that one, you're gonna do a little bit more work, but I chose to skip this process for now because there's only a single service in my cluster, but looking into the future, it's definitely of a good use. Lastly, I wanted to demonstrate you this testing section. It's gonna give you a little bit more power how you go about testing different things about your solution. So since I have this name associated with my service, let's go ahead and try a couple of things here. NS lookup is going to give us an IP address associated with this domain name. Nmap is a port scanner. It's going to tell whether ports are open and or not. And it actually is telling us that these two are open. That's how we configured our load balancer. Anyway, curl is going to send a structured HTTP request to this endpoint. Let's actually try that. As you can see, it's giving us a response from a identity aware proxy, and that is because we put it in front of our load balancer. Since I'm not providing any authentication information to curl, it's not accepting our request and not getting it through. Lastly, this OpenSSL command is that how you test a certificate on the server. If we run this one, it's going to actually give us the common name on the certificate. And that is what your HTTP client is checking against once connecting to the server here, okay? For the final look, let's open up this incognito browser session and try accessing that URL, okay? So as you can see, I'm faced with this authentication page, and that's our identity aware proxy kicking in. That's where I gotta specify my email for who I allowed it to, okay? So other emails won't work. So I'm gonna use my password as well. So I'm gonna confirm it on my phone. There's like a lot of security measures in place, okay? It's getting us through onto the web page with our configured service. From here on out, I can just use my app credentials. That's I've also configured already. I'm gonna sign in, and that's where I can start working with my service.
I genuinely hope it's been somewhat helpful for you guys, because it took me quite a bit of time to put it all together up to this point where I was able to release this video. I'm actually planning to stay on this mission of publishing something deep, like a small project of such, on a monthly basis to keep myself and you guys engaged in this technical journey. I really hope it's triggered some interest in you, so you want to go ahead and try a few things yourself. And don't be afraid to break things, because that's how you learn and become better at anything you do every time you figure it out. And you can always rely on me in helping you out. As long as I have capacity, I'll come help you. I'll do my best. Just stay engaged, subscribe to everything. I have no idea how it works exactly, but we'll figure it out. Having said that, I wish you good luck, and I'll see you again very soon. I'll see you again.